Welcome everybody, I'm Mohamed Wahba, Revit expert. As we talked before about how to model foundation for our project, and we used here in our project in our Revit model isolated footings, and we use also structural slab foundation to accomplish my foundation. So I will continue my previous work to create the columns and the grade beams in this video. So we need to review also the column cross sections and dimensions of column. Here we have 4 models of columns. So we need to create a models of these columns firstly by clicking here on column command. We can see here previous models of column. So we have to check firstly the family of this column, because we have a rectangular I section for steel structures and so on. If we didn't find here the cross sections that we need, we might check our library to bring it here. So we need firstly, if we can find here the rectangular, for example, that we need, we have to check our library by pressing here on insert and load family, and we can move through this library to check structural columns, not columns only, because we have here a column that's for architectural model. Here we can see a column, not this folder, because that this folder related to architectural model. So we have to check the structural column. We can see here columns are classified according to its material: concrete, steel, wood, precast, and so on. I will choose concrete, and for example, if I want rounded or square or rectangular, I will choose it. So when I open this, it will appear in my command area. So I will choose column, and also I will choose rectangular ones. As we've made before, the isolated footing, we have to check edit type and duplicate to create another one. So my sections are 250 by 400 millimeters. So I will write it here, 250 by 400 millimeters. So 0.25, 0.4, duplicate another one. Here we can find 240, 400. Point 2, duplicate another one, 200, 600, 0.6, duplicate, and 700, 0.7. So we now created all the required columns here. I want firstly to draw this column, so I have to bring the required view. So I will start here from RC. So we need to connect our column between to make a connection between RC and the grid beam, and then we will replicate it to connect grid to first story to second, and so on. So let us begin here. When I check this columns, I can choose column here, this order, this command, and firstly we have to check some important points here. Firstly, I will choose column. For example, I will start 200, 400 by 400, and I will check here the level. But before I check this level, this column is vertical ones, so I will choose a vertical, not inclined or slanted. So I will choose vertical column. Then I can check here. I stand here above the RC, and I will connect it to a grid. So I will choose not depth, I will choose height, because I will move up. So for height to the grid, I think some people want to check finally to the second, but I will suggest that to move it only to the grid, and then to replicate the individual column to the other required level. So I will choose grid, and then I have now in my hand in the mouse the required column, the required dimensions, and to move it through our column. If when I click here in any place like this, you can see this column has been drawn. 250 for the horizontal and 400 for the vertical. When you press on your keyboard space and click again, you will see that this column, the orientation has been changed by 90 degree. So draw that. I will press space and draw here this column, and here I think I can draw one vertical and one horizontal, and to copy this ones. For example, I will draw one horizontal like this. Get out of this order. To know the column that has been drawn, I will shut down all the foundation here. So I will click VV on my keyboard and choose here the model category, and I will shut down all the foundation categories, like structural foundation like this. Okay. To know the number of columns that have been drawn, so I draw 1, 2, 3. So I will copy this column. I'll choose multiply to repeat this order. So I will draw it here. The vertical ones is here also. So I finished all the vertical ones. When I draw this column here, this specifically not its cross section, I can get out of the order and choose this column and change the properties of this column to be, for example, 200 instead of 250. So I will adjust this column by using move command. Then I can copy this column again here. I will do the same order, for example, for this column. This column I think is 700. I'll choose it. No, it is 600. I will adjust it to be commensurate with its layout like this. Copy. I think it is 700. I can adjust the column by using arrow in my keyboard, so I will copy it. think it is more than the original one, so I will decrease it to be 600. I'll copy it. We need to adjust this one again, this column again, so I will click on it and use and press MV for summon move command to move it like this. So we have 1, 2, 3, 4, 5, 6, 7, 8 columns haven't been drawn, so I will choose this column for example and copy the other ones. We'll adjust this column. So I think I have finished all the columns here in my layout. So I'll check it in the 3 dimension. You can see clearly here the full number of columns on my foundation. We need now to draw the grade beams. So I will choose here the level grade beam, and I will need to summon the grid beam layout from this drawing. So I will copy this layout to another sheet here in AutoCAD. I will save this file as a grid beam. Here in my file. So we need to insert this file here above this. I will, for example, shut down all the layers of foundation, and then I will press insert and load and import the AutoCAD file. It is here, so I will choose black and white, and dimensions were millimeter, and so I will choose it for example origin to origin in the grid beam. So it will come here. We need to orient this drawings to be above the same one there, so we have to check the bin command. I will select the pinned elements and remove the bin here, and to move it from this point to the same point here, to be oriented in the same position and same location in my drawing. So I will bin it again, and deselect the bend, select the bend element. So we need now to draw the grid beams. We will have a lot of options here. Firstly, we need to define the cross section of beams by clicking here. We can see here some cross sections, we need to create and define rectangular concrete beam. If we can find it here, we can load this type from our library. It is structural free. For example, I will choose concrete material and choose any one from those families. So it's already here, so I will choose concrete, rectangular, and duplicate it. I think the dimension of these grid beams, we need to check it here. That's the grid beams, 250 by 600 and 200. So it is grid beam 250 by 600. Another one, it is 200 only by 600. So we need to draw this those beams. Firstly, we have to check this orders. We can check it here by using it is beam number one. It is beam number one. Its cross section is 250 by 600. So we need to make it clear here. I will choose 250 firstly, and then we need to check the justification of Z and Y direction. If we choose Y direction, it is the way when we draw this beam from the left side or the right side or the center of this column of this beam. So for example, when we choose, for example, center, we need to draw this to draw from the center line of the beam. For example, I will choose if we can't find the center line, we can't draw this beam. So here I can't find the center line because this line isn't in the center line of the beam. So I will choose, for example, the left. The left is clear here. We can draw from this point to this point. That is the left of this beam. If I draw like this, you can see this beam has been drawn. So we need also to make it shaded, for example. I think we now understand what's the difference between left, right. If I choose right, for example, I will draw this beam like this from this point to this point. I draw this beam from its right side. So I will repeat this order again and again. So I will draw this beam like this. We can choose here a chain if we want to continue our drawing like this. If I draw this beam, you after clicking the second point, you get out of the beam. So I will choose chain to continue this beam like this if I need this order. So I don't need this order here. I will continue drawing those beams, grid beam. I need to draw this beam here. And here. GB1 from its right side. We can draw all those beam easily, or those beams easily here. You have to be carefully when you draw those beams to be on the right side of the beam, like this. It is also grid beam number 1, so I will choose to draw this and get out to draw this beam. It's a cross section, I think 200 only, so I will choose select it and choose 200 from this selection, so it can clearly be seen that the dimension of this beam is adjusted here on its layout. So I need again to draw this beam. I will choose also any grid beam from here and write CS to create similar. You can do that faster than the previous order. Here we can get this beam from the right side. Here I think we need to finish this one. I think we're finished. We can check it from the 3 dimension and to erase those beams, and also we can press VV to shut down all the grid beams layout. We can check those beams here in my layout. So I think we now finished all the grid beams. We have to continue. We need to draw the columns above those beams, to extend those columns to reach out to the other levels here in my structure. So I will choose here. We can do that easily here. When we choose the grid beam level, I need only to select all the columns here in this selection to copy it or replicate it to another levels. We can do that easily when we choose all those elements and filter all those elements to choose only the columns, structure columns only. So I will choose the columns only. We now choose the columns only and copy it from here, and then we can paste all depending on the level. So I will choose the level of first story. The first story. We can check it here and to move through my drawing, but unfortunately we can find the height of this column only as the height of the previous column. So we can adjust this. How we can adjust this? We can select all those columns and we can choose from here. I need to say that we need to start it from the grid beam and without any base offset. I will write 0. I need it to reach to first without any top offset. So when I move the mouse on the screen, we can choose we can see this adjustment has been made. So it is important to do these columns separated like this. We now need to get the slab from my drawing. We need firstly to draw the slab on grade in my structure. We can check it here in my drawings. Slab is here in the same layout. Its thickness I think is 100 millimeter, and we need to draw it around my drawing. So it can easily be drawn here when we choose a grade level, and then we can choose floor. We can draw it by using the floor command. Structural, we need to edit it as we've made before, so we can duplicate. I will say that slab on grade. Its thickness is 0.5, and concrete can choose it. For example, custom release to be commensurate with the other types. Here I will delete this layer. I can delete it from here. I need only 100 millimeter with the structural function, structure function, and this material. So I defined this beam, this slab here. I can draw it on the grade level. I can offset my drawing by writing here the distance and the level that we want to offset it. So I can make my drawing. We can draw this slab by a lot of methods. First, we can choose line, rectangle, and so on. I prefer to use a big lines. We can pick on those lines like this. I will choose this line and pick this line, for example, and eventually we can connect all those lines to make the parameter of my slab. That's a very easy method to connect and to draw my slab. I can choose here trim extend to corner, this order. I will connect all those lines, click on the both sides of the lines like this. It sounds like the fillet order in AutoCAD with a radius 0. So when I finish, I can press here finish. So it can clearly be seen that we now finished my my grid, my slab on grid. So there is a point we need to check here. Beam, when we draw this beam, we can check here the Y justification. It is left, right, and center, and so on. But Z justification, when we draw this beam, we need to draw it from its top side to make it drop the beam. For example, if we want to draw it as inverted beam, we can choose bottom to draw from its bottom side, or from center to be dropped from its two levels. So here I choose a top. We can check it from the 3 dimension. For example, when I press on this beam, I can when I choose here bottom, it can convert it to be inverted beam like this, or center to be dropped from its both side. So I need here to be for this beam to be dropped. We now finished the slab on grade. So the next step, we need to draw the slab of the first story. So we choose this slab on the first story, and we need to summon this slab from AutoCAD. I will pick it up and to make it in another sheet like this, to paste it here as we've made previously. And to save this file as, for example, slab first. I need to check points also here. I use AutoCAD here 2016. So here I saved it 2013. Revit must be above this version, so I use Revit 2017, and for example AutoCAD 2013. If I use AutoCAD more than 2017, it will not be open. It will not open there in Revit, so you have to check this point again. So I need to summon this this file, the AutoCAD file from Slab, black and white, millimeter, all the layers, center to center or origin, and I will choose open. I need to adjust this file. I will choose here. I need to select the bend elements, choose it. I will remove the bend elements and move it, adjust this layout to be commensurate with my layout and my structure, and then I will bend this file and choose here. I don't need to select the bend elements, so I can draw the slab here. So firstly, this slab is 22 centimeters, so I will define it firstly from here, duplicate another one, it is thickness 22 centimeter. I will edit another one to be 0.2 concrete, and I will do the same order here. I prefer, as I said before, big on the external side of the slab like this. So we need to check something very important here. We need to open this area for a stair. If we need to do something like this, we need to draw a closed loop here on the side, on the area of slab. Like if I draw a closed loop like this, it will be opened. SZ to go to the first point. I now finished this closed loop. It will be opened when I finish here my slab. So I will check it in the 3-dimension view, VB to close and shut down the slab AutoCAD file. Here we can see the slab of this structure. So what I need to do next is to draw the beams on the parameters of this slab. I will choose first story again, and I will choose beam. Its section is here in the design sheets. (250 by 600). We have here 3 types. Two of them are the same, have the same dimension, and 200 by 500. I will choose here edit, duplicate another beam 250 by 600. It is B1. I'll choose also right, for example, top to be dropped beam, and I will draw it like this. Or remove the chain. I need to pick the and snap on the endpoint. We can check here snap override and check endpoint to get this point easily. It is also beam number 1. It is a flat slab with a marginal beams on its parameters. So I think that we finished now the marginal beams. We need here beam number 3. It is 200 by, we didn't do this. I will choose duplicate. It is 500 by 200. I have to check it here. 200 by 500. From its right, we can draw this beam. Now we finished all the required beams here in my structure. We can check it here, save my structure. Now we can check my structure. We drew all the required beams in my structure. Let's begin to draw this stair. When we start here over this first story, we can choose here from architecture stair by component, and we can choose the monolithic stair that can be casted in place. And then I will duplicate another one. I will make it 20 centimeter. Those are some calculations if you want to stick to make some restrictions to the riser height or the tree depths or the run width. We can choose the thickness and the type of run and type of landing. I will choose it here. Duplicate another one. I will choose its thickness 20 centimeter and its thickness 0.2. I will remove, I don't need slanted ones. So the same for the landing types. I will duplicate it to be 20 centimeter and I will choose its thickness 0.2 like this. Okay. This stair will connect the grade level, for example, and the first slab. The number of those stairs are 28. You will write here 28, and the depth of the tree is 30 centimeters. So I will draw the stair here. The width of the run is 1.2 meters, and when I draw the stairs I will choose the left side. For example, I will draw from this point this stair like this. I will stand here. So this message is warning you that you have some it alert you that you have to check the minimum thread depth that you've made, because we wrote here 0.3 and we have to check it here because we wrote here the minimum thread depth supposed to be 0.3048, so we need to make it 0.3 that we don't exceed this number. So so this software alert you have to make check on this depth. I stand it here. That is the number. It is 19 for the riser, and I will click from this point to finish it here. So I drew here 28 risers. We can adjust this stair by clicking on this arrow and to drag this arrow to be commensurate with our structure like this. If we need to commensurate the structure with our structure like this. So when I finish, I will click here. This message tells you that we have some troubles with the handrail, so I don't care about it. I will this stair doesn't appear here in the 3D view. We have to check our visibility VV. It doesn't appear here. We have to select the stair from this selection. We can see it here clearly. So we need to check this stair. We have here some troubles. We need to check this trouble. How can we solve this trouble? We have a lot of solutions to do. And firstly, we can stand here above on the first story and to make a section in this stair to see these troubles. I can make section from this or from view section. I will draw it section and I will choose this section, this troubles that I want to solve. How can we solve this trouble? So when I check and select this stair and edit the stair, when I select this stair again, we can see here from the construction that we've ended this stair with riser. I don't need riser at the end. I will deselect this to end with a thread and to drag this to increase another one. So when I finish, it can clearly appear that we've solved this trouble. This is one solution. There are another solution we can make. When I undo this, what I have made before, that I can solve these troubles by modeling this merged triangle here on place, by making here a reference plan to view this plan clearly from the structure. I will choose here reference plan and I can draw this plan and name it as, for example, stair 1. I can choose here model in place and choose the category is stair and name it. We can draw this triangle here and then to extrude this view, but first we have to choose the workplace from this, the work plan, and I will choose the reference plan was a stair 1. When I check here OK, the program will ask you that you need to check this view from the west or the east. That I will choose, for example, east. I will view this view from the east, but I can't see here the troubles. So how can I solve it? We have here some solutions. I can make the visibility here wireframe to see these troubles, to see through the beams and slabs and so on. So I'll choose it here extrusion, and for example I want to draw this mesh triangle by drawing here, by picking above this line. I can't attach this line. I will draw it by a straight line like this. I can pick this line. I will choose trim extend two corners like this to make it commensurate with our structure. So I will finish, but before finishing it, finally here we can check the depth of this extrusion. For example, I started here from 0, for example, but the depth of this triangle is 1.2, and the concrete is, and the material is concrete. I will choose custom place and finish. When we check this stair, we can find it that we need to reverse the distances of meat. That I will edit the edit in place, and I will start here by 0, and to reverse it to be to start with 1 minus 1.2 like this. I need also to adjust it to move it to finish with the edge of my stair. Then I will finish. It is another solution also that we can make to make our stair commensurate with our and to connect with our structure and our slab correctly. So we've made now our stair. When we need to then we need to replicate stair columns, beams, slab to another one if it has the same statistical system. So I will choose and select those elements and copy it to the level of second one, the first one. So the final level here is the roof. So I will attach and I will copy the 4 columns here on the stairs, that where our stairs is supported on them. I will choose those 4 columns. For example, I will stand here on the second level. I will select those columns and copy it, and then I will paste it in our roof level. Then I will check it here. Then I need to draw the slabs on the roof level, so I can get it from AutoCAD. I draw it here, so I need to insert this file in my Revit file. So I will insert this file from import AutoCAD as we've done before. So I will choose roof, black and white, millimeter, and so on. To make it commensurate with our structure, I will choose select the bend elements and to unbend it, to remove this construction, to remove these restrictions, to move it to be above our structure. So how can we do that? I can drag it and move it from this base point because I can see it clearly here in my structure. So I will bend it and deselect the bend elements. So we can draw our slab here. We can choose slab. Its thickness is 20 centimeters. So I will choose a 20 centimeter. I will create another one, define another one, thickness 20 centimeter. Its thickness is 20 centimeter. I think the previous was 22, so I made mistake here. I will correct it to be 22. So I will back to my 20 centimeter slab of centimeters, so I will choose rectangular, and then I can draw it here. We've had here 4 beams, beam 3, model 2, and so on. So I will choose here beam. Its dimension was 200 by 500, so I will hold it from its right side, and then I will draw it like this. Then I have another beams. Its dimension was, for example, its depth was 200 by 600, like this. So it is my structure here. We can finally check our structure when we view it in the 3 direction, in the 3D view. So we can stand here and to shut down all the imported AutoCAD in this view. We can check our structure here at the 3 dimension. If you found this video useful for you, please like, share and subscribe my channel to get my latest tutorials, and you will find me below to reply your comments. Thank you very much.